Now, a little bit more on exponents, important stuff to know on exponent before we get to integral expressions. First, we already know that when you have a to the n power, a being the base and n being the exponent, that means a multiplied by itself n factors, or n times. As an example, 5 to the third power means 5 times 5 times 5, 3 times, and which is 5 times 5 is 25, 25 times 5 is 125. That's what 5 to the third means. Okay? Very important to remember, a to the 0 power, or for the matter of fact, anything to 0 power is equal to 1. So it can be, for example, 32 to the 0 power, that is equal to 1, or it can be 2x plus 5, the whole thing to the 0 power, that is also equal to 1. So anything to the 0 power is equal to 1. Need to remember that. Also, when you have a negative power, a to the minus n power, a to the minus n power is the inverse, is equal to the inverse 1 over a to the positive power. So a to the minus n power would be equal to 1 over a to the n power, and a should not be equal to 0. Right? So 2 to the minus 4 power is actually 1 over 2 to the 4 power, which is 1/16. So again, if this was an expression, it would mean the same thing, 3x minus 15 to the minus 2 power, that is equal to 1 over 3x minus 15 to the second power. So even as an expression, the same rule would apply. A negative power would mean you have to write it in inverse situation with a positive power. Laws of exponents. The first law of these laws of exponents we already seen, and we have used it. The first law of exponent. A to the m power times a to the n power would be equal to a to the m plus n. So if you have the same base, both of them a, right, multiplied by each other, it has to be multiplied by each other, by the way, not a plus, not a minus, has to be multiplied. A to the m power multiplied by a to the m power, you write one of the bases, you add up the powers. As for example, h to the third times h to the 12 equal to h to the third plus 12, which is h to the 15. In this one, you have, in this example, you have a variable. This could be numerical. It could be a number. So for example, you can have 2 to the second power times 2 to the third power. We are saying you should write that as 2 to the fifth power. Add up the power, right? A test of that would be 2 to the second power is 4. Multiply 2 to the third power is 8. That should be equal to 2 to the fifth power, which is 32. What is 4 times 8? 32. So 32 is equal to 32. So that's kind of a proof of this law. The second law of exponents says that if you have a to the m and the whole thing to the n power, you write a and you multiply the powers together. M times n, so that would be mn. So you have a to the m times n power. As an example, it says 3 to the fifth, and now the whole thing to the sixth power. You write the base of 3 and multiply 5 by 6. 5 times 6 is 30. So it would be 3 to the 30th power. This is the second law. The third law, if you have 2 divided by each other, see, right in the first one, we have a to the m times a to the n. You're multiplying. This one says, what if you were dividing it? A to the m divided by a to the n, right? You write one base, you subtract the power. You write one base, you subtract the power. Whereas here, when you were multiplying, you added the power. Here you would subtract the power because you're dealing with division instead of multiplication. So y to the 14th power divided by y to the 12th power, it would be y to the 14 minus 12. The one in the numerator minus the one in the denominator, 14 minus 12. That would be y squared. The fourth rule, or law of exponents, say if you have a times b to the n power, again multiplication, a times b, ab to the n power, you can have this separated as a to the n times b to the n power. So if you have multiplication, again, this cannot be a plus or minus, only multiplication, a times b to the n power. So here you have 3 times r to the 4th power. That means 3 to the 4th power multiplied by r to the 4th power. 3 to the 4th times r to the 4th. So 3 to the 4th is 81, and r to the 4th would be. Again, this could be number. Let's say you have 2 times 3 to the 2nd power. We are saying you can write this as 2 to the 2nd power multiplied by 3 to the 2nd power, right? What is 2 times 3? It is 6. 6 to the 2nd power, we say, is the same as 4 times 3 to the 2nd is 9. What is 6 squared? That is 36. Equal, what is 4 times 9? 36 also. So that's a proof of this law here. Again, you have to know it is multiplication here. 3 times r, a times b. If it was a division, such as a divided by b to the n power, that one can also be separated. It would be a to the n power divided by b to the n power. So you can have that for multiplication. So for division and multiplication, you can separate them from a parenthesis. So it would be a to the n divided by b to the n. 4 divided by h to the 3rd power would be 4 to the 3rd power divided by h to the 3rd power. So 64 divided by h to the 3rd power, right? So I could have done this as let's say as a real number. So 2/3 to the 3rd power would be 2 to the 3rd divided by 3 to the 3rd. 2 to the 3rd is what? 2 to the 3rd is 8. 3 to the 3rd is 27. So that's what 2/3 to the 3rd is. These are the laws of exponents, which we are going to use in simplifying polynomials and rational expressions. So you need to know that. So here it says simplify each of the following. Simplify each of the following. So you have 3x squared multiplied by 2x to the 4th to the 2nd. This power of the 2nd only applies to the 2nd parenthesis. It had nothing to do with the 1st parenthesis. As a matter of fact, the power of the 1st parenthesis is only 1. Right? So before you can multiply the 2 parentheses together, first you have to take care of these 2. In other words, the inside of the 2nd parenthesis need to be raised to the second power using the laws we just saw on the previous slide. So I'm going to keep the first one, 3h squared, first. Now this one, 2h to the fourth power to the second power, that means 2 to the second power, which is 4, and h to the fourth to the second power would be what? H to the eighth. So here would be 4h to the eighth. Now you can multiply the two parentheses together. 3 times 4 is 12. And h to the second times h to the 8, you write one base and add up the power using the laws you saw, the first law you saw on the previous page, which is 10. So 12h to the 10 power. I'm going to use this one at the bottom also before I clean it and see what they have done on the slide themselves. So again, since everything is multiplication, h to the minus 2 multiplied by y to the 6 divided by h to the third multiplied by y, everything multiplication or division, I can take each one of them and raise it to this minus 1 power using the second law of exponent. So x to the minus 2 to the minus 1, you write the base and you multiply minus 2 by minus 1. Minus 2 times minus 1 is 2. Y to the 6 to the minus 1, you write the y, and 6 times minus 1 is minus 6. In the denominator, h to the third to the minus 1 would be h to the minus 3. And y to the 1 to the minus 1 would be would be y to the minus 1. Okay. Now anything with the negative power, as you have seen in the laws, you can switch it from numerator to denominator and write it with the positive power, or from denominator to the numerator and write it with the positive power. So that's what I'm going to do. The h squared already has a positive power, so I'm going to keep it as h squared. In the denominator, I have h to the, so let me get rid of that. In the denominator, I have h to the minus 3. I bring that up and write it as a h to the 3. I also have y to the 1. I'm going to bring it up and write it as y to the 1. In the numerator, I have y to the minus 6. I put it in the denominator and write it as y to the 6. Now, everything has a positive power, so I'm going to combine the terms. So h to the second times h to the third, using the first law of exponent, that would give me h to the fifth. Y to the 1 and y to the 6th equal. The y to the 1 in the numerator is going to take away one of these 6's, and y to the 6th would become y to the 5th. So therefore, this would be h to the 5th divided by y to the 5th. Or I can write it maybe as h divided by y to the 5th. I can combine it under one parenthesis if I want to, since they have the same power. Or I can leave it as it was. Now we're going to see what they done it on the slide themselves. You should be coming up with the same answers. Maybe a little bit of different ways of getting to it, but nonetheless, the final result should be the same. Again here, as I said, you raise this one to the second power, which would become 4h to the 8th. Now you can combine the two. 3 times 4 is 12, h, and add up the power, h to the 10th. That was easy. This one, again, each individual one raised to the minus 1 power. So this would become h squared, this would become y to the minus 6, this would become h to the minus 3, this would become y to the minus 1. They didn't show it, but they brought it up and came with the h to the 5 and canceled this one with that one. One would be subtracted, it would be y to the minus 5. Then it goes into the denominator as y to the 5th. So it's the same answer we had moments ago.